Alright, the last part of this unit is going to actually solve equations using, or that involve, exponential and logarithmic expressions or terms. So, our little key concept box there says that if we have 3 to the x and it says that it equals 3 to the 5th, then x is equal to 5 because it's in the same value. We have 3 to a power equals 3 to a power. What is that power? 5. So when they're in the same place with the same base, they're equal to each other. So we can say then that 3 to the x is equal to 3 to the 5th. So if we look at our examples here, there's really 2 ways to solve exponential functions. So I would say that the 2 ways would be to create equal bases, or undo the exponential part of your equation. So we're actually going to look at a way to do both of them. So we're going to look at number 2 and we're going to look at number 6. Actually, we're going to look at number 1. So if we take a look at number 1, it says solve the equation, and it gives us 4 to the x equals 1/2 to the x minus 3. So what I would do here is I would say, okay, if you have an exponent on each side, then you cannot solve this by undoing it. If you have an exponent on each side, then you have to create equal bases. So if you look at number 3, there is not an exponent on each side. So in that case, we would be able to undo it. But when you have an exponent on each side of your equal sign, you have to create equal bases. So you have to think to yourself, okay, what could I rewrite 4 and 1/2 as with the same base so I could make them equal? Well, they both look to me like they're some sort of multiple of 2. So we can rewrite these as a base of 2. So how would we rewrite 4 with a base of 2? Well, 4 is equal to 2 squared. Hopefully you agree, and you still have your x outside there. Is equal to, what can we write 1/2 as? Well, 2 to the negative first. 2 to what power is 2? 1. It's fraction, so negative. And x minus 3 is still out front there. So we have the same bases, but we don't have a single simple exponent. So what we want to do is we're going to take this power to power, which means we multiply. So 2 times x is 2x, and negative 1 times x minus 3 is equal to negative x plus 3. Now that your bases are equal, we can cancel the 2's out, and you're left with 2x equals negative x plus 3. And then you guys can just solve by getting your x onto the one side, and the last step is to divide. So x in this case would equal 1. And we know that because we created 2 terms with equal bases so that they canceled out, and we could set their exponents equal to each other. Okay, number 4 and number 6. So number 4, like I said, for 4 and 6, they do not have an exponent on both sides of the equal sign. So we are going to have to undo the exponential part. To undo an exponential, you guys know that you have to turn it into a log equation. But first, we have to get that exponential part by itself. So we have to get rid of that too. So 4 to the power of x plus 3 equals 7. Okay, to undo the exponential, we take the base of the exponent. It comes over and becomes the base for your log. So we have log base 4 of what was on the right-hand side. 7 equals x plus 3. So here's where that change of base formula comes in handy, because I do not know off the top of my head what power to raise 4 to get to 7, because it's going to be a decimal, because it does not work out evenly. So, to solve for the log base 4 of 7, we would have to use our change of base formula. So what is ln of 7 divided by, my goodness, ln of 7 divided by ln of 4. So you guys would really just do that in your calculator. And it looks like I get the decimal of around 1.404. So what's the last step to solve for x? You just subtract 3 from both sides. So what is 1.404 minus 3? X would be equal to around negative 1.596. And that's it. So we just undid our exponential part of our equation. We got it by itself and then undid it. And used our change of base formula to solve, or to help us solve it. So last one on this sheet, we are going to do number 6. So 4 times e to the exponent of negative 0.3x minus 7 equals 13. So again, we want to get this e, the part that's being raised to the exponent, by itself. So we have to get rid of the 4 and the minus 7. So we're going to add 7 first to both sides and get 4e to the negative 0.3x equals 20. Still don't have that e to the negative 3x left, so we have to divide both sides by 4. So we have e to the negative 0.3 x equals 5. So we have to undo the exponential. So we're going to take the base, which is e. How do we undo e? With a natural log. So the e is now gone, and we're left with negative 0.3x equals the natural log. I don't know why I keep drawing h's. The natural log of 5. And then the last step to get x by itself is to divide both sides by negative 0.3. So, in your calculator, do ln of 5 divided by negative 0.3. And I get, it looks like approximately negative 5.36. And that's it.